open the GMB1 current sources, find V to find VO, and looking into one of GM resistance, straight ahead, V in between V in and V out, written down from this directory. This is not basic procedure to derive the Thevenin equivalent. Basic elemental procedure doesn't say from here to here, but we can write down this from inside, just inside. V in minus V out equals V1, and this generates current, and in other words, V in minus V out divided by 1 over GM equals this current, and so this is equivalent. So in two ways we can generate straight ahead and regulating current sources, and same approximation showing control voltage and finding out VO, which is V in here, or straight ahead V in minus V out divided by this virtual source resistance makes the current flowing through one of GMR, flowing through these spots, which is GMV1, V1 because V minus V out. In both ways, we can from now transfer the topology to easy way, effective way to find out AV. AV here just V out V in over V in equals voltage divide of V in with 3 resistance, 1 over GM and 1 over GMB. So voltage gain of source follower is voltage divide of this Thevenin equivalent. Just elementary Thevenin equivalent approach doesn't say with current source and voltage source coincide with parts, those kind of parts. So some other way to find out Thevenin equivalent voltage. And there's no contradiction within these relationships. Relation. KCL, KVL, Ohm's law, Thevenin equivalent, not equivalence, and principle of superposition. Principle of superposition, POS, superposition, principle of superposition. Principle of superposition, there are no V1 minus V1. Green showed it, there's minus V1, but current source is open to find out V out, VO for Thevenin equivalent. So just after applying principle of superposition, there's no V1, so VO equals V. If there's V1 and without current sources, if there's V1, we need to add some V1 or minus V1. Correctly inspect the direction. Direction means positive or negative, or voltage, current direction, or voltage, or how to say. This is direction, and this is positive, negative, voltage, positive, negative, voltage, polarity. So yeah, polarity, polarity, polar, polarity, polarity. I use rarely the word polarity, but sometimes watching in the textbook. Polarity, or any other better expression there for voltage directions, positive and negative, or negative positive. Anyway, inspection with enough care for polarity and directions of voltage and current respectively makes us find an easy way to solve a problem, analog circuit problem, to survive, to make possibility to survive, or possibility of survival higher. Because the calculation leaves human errors and make some time cost time like this. But once we think over and over again and find an easy, simple way, less errors, with making us less errors, is very effective way to act, tackle the problems. So think about the problem and how to react to the problem is different, and it's important to how to think about how to effectively so it's not time loss for us to thinking over one and try and error, and finally getting the result of something useful is not just a cost, not just a loss. Creating the method, effective, useful method in creating survival probability point plus 0.1. From here we might be added the probability 0.1 to a survival. Maybe.